Good morning. Going to talk a little bit about tissues today, and not the Kleenex kind. That's funny. Okay, so first thing, in your body, when we talk about tissues, we talked a little bit about it the other day with the pyramid. That a tissue is basically a bunch of cells working together to perform a job. The key thing is that they have to be working together. They have to be kind of doing the same thing. It doesn't really work if you have a muscle cell working with um, I don't know, a nerve cell, which I guess normally they would. But they've got to be working together. So a nerve cell in your leg isn't necessarily going to be going to join together to make a tissue with the muscle cells in your heart. Okay, so talking about cells that are kind of the exact same, working together to do a certain job. There are four different types of tissues in the human body. Okay, every single thing in your body can either be an epithelial cell or an epithelial tissue, a muscle tissue, nervous tissue, or connective tissue. So it's going to be one of those four items. Epithelial tissue is the first one we're going to look at. Its job is to form a solid covering, either inside your body or outside. So most of your organs, the outsides and the insides, are going to be made up of epithelial tissue because they're coverings. So these cells are tightly compacted together, so obviously it can form that barrier, can form that covering. You obviously don't want huge gaping holes there in between. The other thing they can do is, like I said, they can line on the inside of your body cavities. So all those different cavities that we were talking about the other day, they can cover like the inside of your stomach. Now the thing with the inside of your stomach is that there's also going to be um, other tissues as well. So like your stomach is also going to have um, some muscle tissue because it can expand and contract. So they are going to work with other types of tissues. It's not just going to be working by itself. So, and like I said, it can also cover organs. Your skin, which is our largest organ, is primarily, at least the outside, is going to be made up of this epithelial tissue. The outside of your heart is going to be made up of epithelial tissue, even though the heart itself is mostly made up of muscle tissue. So there's a couple other jobs that the epithelial tissue is going to be responsible for doing. It's going to provide the body with a barrier. Like I said, just kind of the skin. Now your skin is also made up of some other types of tissue as well. It's got some connective and nervous and muscular tissue in there as well, but it's especially the outside layer is going to be primarily made up of this epithelial tissue, which should make sense since that's what the skin's main job is. It's to provide that barrier, that covering for our body. Epithelial tissue can also be used to secrete products. In other words, it can be used in glands. So like sweat glands, for example. Um, you can also use epithelial tissue to absorb nutrients. So the inside of your intestines, which is your gut, your gastrointestinal tract, we kind of shorten that to gut. I don't know if you've heard that word before. But specialized cells that can extract those vitamins and minerals from our food. So that would be another function. And then the fourth function that it can do is it can also excrete substances. So kind of in your kidneys filter your blood, and then from that they're going to excrete those things into your bloodstream. Okay, so like I said, they remove substances rather than releasing. So that's kind of the difference between excreting and secreting. Excreting is getting rid of a waste. Secreting is releasing something that's useful. So your glands up above there with can secrete products, they're going to release useful things like hormones. Your kidneys are going to remove substances like wastes that we don't want. Okay. There's a couple of different ways that we kind of can describe our epithelial tissue. Um, they we can classify it based on how it's kind of put together, how many layers, what shape um, those those uh, those cells can take. So that's kind of that's how we come up with their names actually for epithelial tissue. So the first shape type is going to be squamous. So anytime you hear about squamous epithelial tissue, it just means that that tissue is flat. If you have tissue that is cuboidal, sounds exactly what it is. It's cube-like, so roughly equal height and width. It's not the same as squamous. Squamous, you might think of square, but squamous means flat. Cuboidal means cube-like. Alrighty. Columnar is the third way, and that means it's column-like or rectangular in shape. So those are the three major ways that epithelial tissue can look shape-wise. It can be squamous or flat, cuboidal or square-like, and columnar, which is going to be more like a rectangle. Okay. So the next part is we can classify your epithelial tissue based on how many layers they're made up of. So if it's a simple epithelial tissue, that means it's one layer. If it's stratified, that means it's got at least two layers. There's a couple of different of stratified, what's the word? Stratified, specific stratified arrangements, I guess would be a better word. So there's a couple of very specific arrangements of your stratified. Pseudo-stratified, pseudo, that prefix there, pseudo, means fake. So pseudo-stratified looks fake stratified, if you want to, like, actually define it. So basically it looks like it's layered, but it's not actually. It's just a bunch of different heights in your one layer. So you might have some columnar cells mixed in with some cuboidal. So it's going to be different sizes. So it's going to look like it's maybe different layers, but it's not actually different layers. It's actually just one layer. So that's why we call it pseudo-stratified, fake stratified, if you will. So, and then the other kind of quote unquote other arrangement is going to be transitional stratified, which means that um, it's transitional, so it's going to be able to be moved a little. So you're going to find these particular ones in your bladder because you need the ability to stretch and relax. Okay, the next set is your muscular tissue. If you are made up of muscular tissue, you obviously are made up of muscle cells, and these particular cells have the ability to shorten and to basically to get longer and shorter in length. Then we call that a contraction. These these particular cells have special names. They're called muscle fibers. We'll kind of dissect those later. So we'll kind of take apart the muscles here in maybe a week or so. We'll kind of look at what makes up muscles. So there's 3 different types of muscle tissue. The first type of muscle tissue is called skeletal muscle. This type of muscle is your typical muscle, what you think of when you hear muscles, or what most people think of when they hear muscles. It's going to be found, I guess I shouldn't say it's found on your bones, not in your bones, because technically it's not in your bone. It's attached to your bone. Probably be better found attached to your bones. So these would be like your biceps or your ab muscles. They are striated in appearance, meaning they have layers or striations. Kind of like back here, stratified, striated, kind of the same thing. So they're going to look like they've got parallel fibers kind of running through them. Depending on how muscles cut, though, sometimes you can't see it, like on your steak, you can't see these striations. However, if you got a larger piece of this, because they're cut transversely, if you had a larger piece that wasn't cut transversely, you would be able to kind of see those striations there along running through. The second type is called smooth muscle tissue, and this is hollow, meaning it's visceral. It's not going to be striated. It's going to be one long sheet or one ring. And you're going to find these lining the inside of some of your inside tubes, like your esophagus. Think of a toothpaste tube. If you've got one, some of them don't work the same depending on, because if they're like of that harder plastic, they don't squeeze it as well. But if you have a toothpaste tube where you kind of have to squeeze and push all that toothpaste through, and you can flatten out that toothpaste tube, that's kind of like how the smooth muscle fiber contracts. It's going to take that tube and it's going to contract at one end and then push all the way down, and that contraction will fall all the way down through that tube, kind of like as you're squeezing all of that toothpaste from one end of the tube all the way down to the outer end where it's going to come out. It's kind of how smooth muscle tissue contracts. So your esophagus, these are going to be found inside of your intestines. The last type of muscle tissue that we're going to talk about is going to be cardiac, and that's pretty self-explanatory. It's found in your heart. That's why they call it cardiac muscle. So I guess I should go back and say this. Smooth muscle is also involuntary. The only muscles that are voluntary, meaning that you control when they move, are your skeletal muscles. I didn't have it written down here in the smooth. I only have it in cardiac, but both cardiac and smooth muscle are involuntary. So you do not control them to a certain extent. Obviously, when you swallow, you're encouraging them to start contracting, but you don't actually control the muscles that make up the inside of your esophagus. Now you've got muscles that push the food back and then start it, but you don't actually control that muscle contraction. So same with your cardiac muscle. The only place you're going to find cardiac muscle is in your heart. They're going to be striated also in appearance. So, but my guess is if you've seen a picture of a heart, you've probably seen the striations there anyway. Would be my guess. Alrighty, nervous tissue. Just like the muscular tissue had a very special name for its individualized cells, so do nervous tissue. So does nervous tissue. So instead of being called a muscle fiber like muscles are, these guys are called neurons. So an individual nerve cell is called a neuron. These particular guys are going to make up your sensory organs, so your brain, your spinal cord, your nerves. Although your nerves aren't, I don't know if they're really considered organs. No, they're not. Just kidding. They're cells. I guess I knew that. Sorry. So really, the only organs are going to be your brain and spinal cord there. So this is a very interesting type of tissue because this is the one tissue that has the ability to conduct electricity or electrical impulses. Okay, so I don't know if we'll have time to get into your nervous system or not much, but basically with your nervous tissue, these guys, they have the ability to, like I said, generate that impulse, but it only goes one direction. It doesn't go multiple directions. It can only follow through one direction. So what that means, your nerve cells, these neurons, have these parts where the electrical impulse can only go one direction, meaning your dendrites are called I don't know if they're really called this, but those are the acceptors of the impulse. And so these are going to take any electrical impulse, pass it through the body of that nerve cell, and then from there, it's going to then leave through the axon, which will then pass it on to another one. Now, they don't actually touch. The axons of one nerve cell do not actually touch the dendrites of the other cell, the cell that's next to it. Okay? So that's what kind of makes this very unique, because they've got to pass along this message, but they don't actually touch. So kind of interesting there. But they basically secrete these chemicals and the electrical impulse, and that's kind of what passes along your nerve messages of, hey, that's a really hot stove, maybe I should remove my hand or something like that. So the thing about this particular tissue, this is the only tissue that can't be regenerated. My guess is you probably already know that. You know that we can't regenerate this tissue. Once it's gone, it's gone. It can't be reinstated. It can't be reformed. It's gone. And the reason why is that your nerves, now, okay, I should back up. Your nerve cells can regenerate. However, what ends up happening is they grow so slow, your nerve cells would grow so slow that the tissue that that particular nerve services would basically get deprived of all nutrients and oxygen before the nerve had time to grow back. So, for example, my mom does stained glass. She likes to do stained glass, and so that's I'm sure you've seen those in cathedrals and churches. Those pieces of glass that make up pictures. So anyway, she accidentally dropped a glass on her wrist one day, and it kind of nicked her. And what it ended up doing is it nicked one of her nerves. And so she lost feeling in the middle of her palm, and then she lost the inside of her middle finger and the inside of her ring finger. She couldn't feel on the inside of her middle finger and her ring finger, and she couldn't feel part of her palm. So what ended up happening is her nerve did grow back, but she only regained feeling up to about the middle of her fingers, because the nerve grew so slow that the tissue that allowed the nerve that would have allowed her to feel the upper part of those fingers, just it didn't get the nutrients it needed fast enough. So it's kind of why we say it can't be regenerated. It can technically be regenerated, but it just can't go fast. It can't grow fast enough, because in time for it to still get all those nutrients and be connected with the rest of the body. So it ends up dying. That remaining nerve piece just ends up dying. So, all right, the last type of tissue is called connective tissue, and this is kind of the lump all category. Basically, if you are an epithelial tissue, a muscular tissue, or a nervous tissue, you're going to be a connective tissue. So it's hard to come up with one particular definition for these. Basically, we just say it's there to bind and protect and support your body. Connect it. So it's the most random assortment of body parts, I think. Your bones are made up of connective tissue. Your cartilage is made up of connective tissue, tendons, ligaments, all that kind of makes sense. But then your dermis, which is the second layer of your skin, and the lower layer of your skin, the hypodermis, that's all made up of connective tissue. Your blood is made up of connective tissue. Your fat is considered connective tissue. So basically everything else in your body that's not epithelial, muscular, or nervous is called connective tissue. Now, things like your hair and your nails, that's going to be made up of protein. That's not necessarily a tissue. It's a protein. Okay, so with very few exceptions, everything in your body is considered to be one of these tissues, one of these 4 tissues. So, and then these tissues are going to bind together and work together to make an organ. So your heart, for example, is going to have all 4 of these. It's going to have obviously muscular tissue, so it can contract to beat. But in order for it to beat, together, they've got to have some nerves. So that would be some nervous tissue, and then obviously the inside and outside of your heart have coverings to keep the blood inside of your heart. So that would be your epithelial tissue, and then you could consider the blood going through your heart as the connective tissue, but your heart does have some fat kind of surrounding it. So that all 4 of those types of tissues working together in that one spot would make up your heart. So that's why we kind of say these, they work together. So hopefully this makes sense. If it doesn't make sense, as always, please just make sure you holler at me, and I'll be more than happy to answer any questions that you might have. So tomorrow we'll probably look at the integumentary system, which is your skin, hair, and nails. And I'll probably have you take a quiz here towards the end of the week. So just be ready for that. I think I've already told you that, so this shouldn't be news. But it'll probably be on Friday. So, like I said, any questions, please let me know. Otherwise, have a good day.